Hi, in this video, we're going to be looking at the geometric sequence, which consists of a general formula of Tn is equals to a multiplied by r to the power of n minus 1, right? So the first thing that we're going to do is to first establish the sequence, right? By identifying the terms of the sequence, and what defines a geometric sequence is a common ratio, which is written as r it's equals to t2 over t1, it's equals to t3 over t2. Okay, so now we're going to look at the geometric sequence. So this sequence here has a general formula of Tn is equals to a multiplied by r to the power of n minus 1, right? So where this a is our first term, this r is our common ratio, and then this n is our term number, or let me just say term number, right? So to establish the sequence of geometric, we're going to say, if we say we want to identify term number 1, term number 2, term number 3, and term number 4, so we're going to use the formula, right? We're going to say if we want term number 1, we're just going to substitute 1 here, right? Where there's n, you put 1, so it's going to be a multiplied by r to the power of 1 minus 1, right? Which will have a multiplied by r to the power of 0, right? So anything to the power of 0 is 1. So our term number 1 is equals to a, right? So meaning here, we're just going to write a. And then term number 2, let me erase this quickly. So term number 2, we're going to substitute 2. So it's going to be term number 2 is equals to a multiplied by r to the power of 2 minus 1, right? Of which 2 minus 1 is 1. So it's going to be a multiplied by r to the power 1, right? Which we don't have to show the 1. So this is term number 2, which we'll write here. So it's going to be a multiplied by r. And then term number 3, let me erase this. Term number 3 is going to be a multiplied by r to the power of 3 minus 1, which would be a multiplied by r to the power of 2, right? Because 3 minus 1 is 2. And then we're going to write a multiplied by r to the power of 2. And then term number 4, term number 4 is going to be equals to a multiplied by r to the power of 4 minus 1, which is equals to a multiplied by r to the power of 3. So we're going to represent this here, a multiplied by r to the power of 3. So these are your terms in the sequence of geometric, right? So a geometric sequence has a common ratio, right? It has a common ratio. So for us to identify the common ratio, we need to divide these terms here, right? All these terms here. So all you need to do is this. We're going to say term number 2 divided by term number 1 will give you the common ratio, right? So what is term number 2? Term number 2 is AR, right? So it's equals to A multiplied by R, which is equals to, and then term number 1 is A, so it's going to be A. So this A will divide out, and then you remain with R. So meaning that that is your common ratio. But to prove that it is actually a common ratio, you need to also test for other terms. So meaning you need to test for term number 3 divided by term number 2, term number 4 divided by term number 3, right? So but sometimes you are all actually most of the times you're given the first 3 terms. So as long as you test the first 3 terms, everything should be fine. So term number 3 divided by term number 2 is equals to term number 3, it's a multiplied by r to the power of 2 divided by term number 2, which is ar, right? So this a, we divide out this a, and then we remain with r squared over r, which will divide out the r, and then you remain with r, right? So you can see that we're having a common ratio r here. Let's try term number 4 divided by term number 3. But as I said, when you find the common ratio, you only need the first 3 terms. So term number 4 divided by term number 3 is equals to term number 4, it's a r to the power 3 divided by term number 3, which is a r to the power of 2. So this a divide out, and then we remain with r to the power 3 divided by r to the power 2, which will give us r, right? So these are the common ratio for this sequence. So for the fact that we find the common ratio, that means this sequence is a geometric sequence, right? So that is how we identify a geometric sequence. Thank you so much for watching. If you have any questions, suggestions, or comments, please write them down in the comment section below. Otherwise, please subscribe to the channel and don't forget to click that bell button.